Hi guys, so today we're going to be learning about rational exponents, okay? And so rational, there's that word ratio, and our most common ways of writing ratios is with fractions. So what this really means is that our exponents this time are fractions, okay? And so here is how we do it. So for any real number b, okay, so that's our base, or inside our radicand, it's our radicand. And for any positive integer n, okay, so it's positive root, okay, b to the 1 over n power equals the nth root of b, okay. The exceptions are when b is less than 0, so if our radicand is negative, and when n is even, because we know that is imaginary, okay. So here, we're going to be rewriting it back and forth with example 1, radical to exponential form, exponential to radical form. So what I often think about is I think of a tree or a plant or whatever, right? So if you think about a tree, it gets its power from the sun, right? And the sun is up high, right? So power is on top. And then for trees and plants, the roots are down in the ground, right? So here are my roots. And so root is on the bottom. And so we're going to take that same thing. So here, when we have some base raised to a power, we can rewrite it. This base becomes inside the radicand, okay? The power is on top, and the root, the radical here, the root, the index is here on the bottom. Okay? Power on top, root on the bottom. Power, root. Okay? You could also rewrite it as this. Okay? Sometimes it's more advantageous to do the power first and then the root. Sometimes it's easier to do the root first and then the power. Okay? So here, as we're rewriting a to the 1/4 into radical form, okay, so power on top, and then the root is on the bottom. So, okay. Or we can, there's no need to write a power of 1, so we can also write it like this. Okay. So here, if we were to change it to exponential form, the power or the exponent is 1, and this is the root, so power on top and root on the bottom. Okay. So why don't you try CYP 1A and 1B and come check your answer when you're done. Okay, you should have gotten 5th root of x, right? Power is 1, root 5 on the bottom is the index. Okay, 1b, you should have gotten c to the 1/8. It's an invisible power of 1 on top, and then root is here on the bottom. Okay, as you're writing these, make sure that it is clear that this is an exponent. It should be higher, kind of in smaller font. Okay, if it is unclear, you will be marked off. Okay. So now let's evaluate this. Okay, so this is 16 to the negative 1/4 power. Okay. So because of the negative exponent, it's now going to be moved to the bottom. And when I move it to the bottom, I change the power from negative 1/4 to positive 1/4. Okay. Then I'm going to rewrite this 16 to the 1/4. Okay, so 16, the power is 1, so 16 to the 1st is still 16. And then the root here on the bottom will be the index. Okay, so here, if we think about what number multiplied by itself 4 times gives us 16, that is 2. And so the answer here is 1/2. Okay? If you didn't know that, you can do your tree. You can see that 16 is 2 to the 4th. So when I do the 4th root of it, I just have the 2. Right? Okay, the next one here is 243. Right? So I'm going to change it. Right? So 243 is going to be my radicand. Okay. Power is 3. Okay. You can put the 3 here, but I don't think we want to do 243 to the third power and then find the fifth root. So I'm actually going to put the 3 on the outside, and then my root here is 5. Okay. Like I said, it's still the same thing as this. Okay. But I don't think we want to figure out this first. It's easier to find the fifth root of 243 and then cube it. Okay. So that's what I'm going to do. I'm going to do my factor tree for 243. 243 is divisible by 3. Okay. It is 81. Right. And then 81 is 9 times 9. And then 9 times 9 is 3, 3, 3, 3. So 243 is 3 to the fifth root. 3 to the fifth power. And if I do the fifth root, that becomes 3. And then 3 cubed, 3 times 3 is 9 times 3 is 27. And so this becomes 27. Okay. If you look at it in your book, there's multiple ways to do it. Okay. And so that's up to you how you want to do it. Okay. But the book shows you other alternatives. Okay. So why don't you do CYP 2A and 2B and come check your answer when you're done. Okay, so for 2A, you should have gotten 1/3, and for 2B, you should have gotten 16. If you got that right, you can move on to the next example. If not, here is your explanation. Okay, so negative exponent, which means since this was in the numerator, now it moves to the denominator, then the power changes sign. Then I rewrote 27 to the 1/3 to be cubed root of 27. Cubed root of 27 is 3, so it's 1/3. Okay. Rewrote this, power on top, root on the bottom. Again, you could do 64 squared first and then cube root it, although cube rooting the 64 might be a little bit easier. Right? That one I already had memorized as 4, so 4 squared is 16. If you did it, that's fine. You can do the tree. 64 is 2 to the 6. Right? So 6 divided by 3 is 2, so 2 squared cuts out. 2 squared is 4, and then 4 squared is 16. There you go. Okay, so now let's move on to example 3, our word problem. But actually, before we get that, let me bring us to the book here. Okay, so one thing we know about rational exponents, so for any non-zero real number b, so if our root here is not 0, and we have integers for m and n, we can rewrite it, right? So again, these are the two ways we can write it, okay? Except for when b is negative, that changes things, and when n is even. There are exceptions to this. The reason why is because it could also potentially be, it can be imaginary. That's why. Right. So, okay. Now we're going to move on to example 3, our real world problem. Okay, so the formula m equals 512 minus 146,230 times b to the negative 8/5 power can be used to estimate the maximum total mass that a weightlifter of a mass of b kilograms, so this is the person's weight, this is how much he can lift, using the snatch and the clean and jerk method. Okay, so according to the formula, what is the maximum amount that 2004 Olympic champion Hossein Reza Zadeh, this should say of Iran, can lift if he weighs 160 kilograms? Okay, so this is his mass. And so what we're going to do is we're going to plug it into here. Okay, so let's do that. So the max he can do is 512 minus 146,230. Okay, his mass is 163, and then to the negative 8 power. Okay. And then here, it's a word problem. All we're going to do is we're going to type it into the calculator. You just need to make sure that you type it in correctly. All right. So depending on how powerful your calculator is or what it can do, that's going to change how you type it in or in what order and things like that. Okay. So I'm going to start by typing in 163 to the negative 8/5 power. So 163, and then I'm going to press my power button, negative, and then this is a fraction, so I hit my fraction button, 8/5. Let's see if I can do that. Okay, so that gives me this part. Then I'm going to multiply it by negative 146,230, so times negative 146,230. Right? And then it gives me this. And then what I want to do is I want to do 512 minus this. So I'm going to hit 512 minus, and then my previous answer. Okay? And this gives me not the same thing. Hold on. Sorry, I know what I made a mistake on. It was because I already included the negative. So when I wrote minus the negative, that's what was wrong. Alright, so then I just added it to the 512. So I get 469.7782, blah, 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 blah. And so then he can lift approximately, the max is about 470 kilograms. And there you go. So then here it says that Jose Reyes, that is winning total, it was actually more than that, 472.50. So compare this to the value predicted by the formula. So what it is saying then is the formula is close. The formula prediction is close to the actual. Close to the actual weight, but it's slightly lower, right? Because 470 compared to the 470. The actual weight, but slightly lower. And there you go. Okay. So why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten either 2.6 centimeters or 2.64 centimeters or 2.639 centimeters. If you got that, you can move on to the next example. If not, here is your explanation. Okay, so here using this formula, I just plugged in 77 for V. Okay, then you got to make sure you're kind of following order of operations and telling your calculator how to do it. So with my calculator, first thing I did was 3 times 77. Okay, then I want to divide by 4 pi. So I have to divide by, and I want 4 pi to be considered together, right? It's dividing by 4 and dividing by pi. So I put it in parentheses. Okay. If you don't, it could think that you're dividing by 4 and then multiplying by pi sometimes. So that's why it's important to let your calculator know what's being grouped together. Okay. So then I got that. Then I'm going to raise it to the 1/3 power. So then I hit my power button, my fraction button, and 1/3. And there you go. Okay, so now we're going to simplify our expressions with rational exponents following our exponential rules, right? So here we have x to the 1/5 times x to the 7/5, right? And if you remember, if I had something like x squared times x cubed, what would we do? We would add the exponents and be x to the 5th. So we're going to follow the same thing. So this would be x to the 1/5 plus 7/5. Okay? And then remember, when we're adding fractions, we need common denominator. I have that, so then I can move on ahead. Okay? Denominator stays the same. It's 5, and then 1 plus 7 is 8. And so this becomes x to the 8/5 power. And there you go. Okay. Here is the next one. So y to the negative 3/4. So negative exponents. I'm now going to move it to the bottom. And then I can't have, this is a radical, right? I can't have that on the bottom. So what I have to do is I'm going to multiply top and bottom to make this 4/4, 1/4, 1/4. And so then this becomes y to the 1/4 over y to the 4/4, which is just y. And there you go. Right, this actually looks a little bit more simpler, but there you go. Okay, so why don't you try CYP 4A and 4B and come check your answer when you're done. Okay, for 4A, you should have gotten a to the 5/2 because 1/4 plus 9/4 is 10/4. Simplify that, that's 5/2. Okay, for this one, you should have gotten r to the 1/5 all over r. Negative exponent, put it in the denominator, but because this fractional or rational exponent represents a radical, we can't have radicals in the denominator, so I have to rationalize this. So if this is 4/5, I need 5/5 to eliminate it. So that's why r to the 1/5, r to the 1/5, and that's what it becomes. Okay, so now we're going to continue simplifying these radical expressions. Okay? So here's our next one. Okay, I'm going to rewrite them, okay, into rational exponents. So this becomes 81 to the 1/8. This becomes 3 to the 1/6. Okay. 81 and 3, I can rewrite 81 to a base of 3, because 81 is 3 to the 4th, right? Right. Then I can simplify this. 4 times 1/8, right? This is power to a power. It's the same thing as when I did this, right? This becomes x to the 6. How did I get it? I multiplied, right? So 4 times 1/8 is 4/8, which simplifies to 1/2. Right? And then now, basically, I can use the quotient rule, right? Because if I have x to the 5th over x squared, this will become x to the 3rd. How did I do that? 5 minus 2 is 3. So same thing, I'm going to do 1/2 minus 1/6. So 3 to the 1/2 minus 1/6. Okay? When I'm subtracting fractions, I need common denominator. So common denominator in this case would be 6. So it'd be 3/6 minus 1/6. So this becomes 3 to the 2/6, or 3 to the 1/3. Okay. Rewriting it in radical form, it'd be the cubed root of 3. Okay. So this is the answer in radical form. This is the answer in exponential form. There you go. Okay, so then let's do this next one. Okay. So here I have 9, 4th root of 9z squared. So first thing I'm going to do is I'm going to just separate them. Right. I can rewrite 9 into powers. Right? So this can be 3 squared. Right? Then I could rewrite this into rational exponents, right? So this is 3 to the 2/4. This is z to the 2/4. 2/4 simplified is 1/2. So this is 3 to the 1/2 and z to the 1/2, which we know then is square root of 3 and square root of z. And so this can simplify to square root of 3z. And there you go. Okay. Okay. Here's the last one. We have m to the 1/2 minus 1 over m to the 1/2 plus 1. So again, this is a radical, right? This is square root of m. So we can't have that. So what we're going to do is we're going to multiply by its conjugate. So I'm going to multiply this by m to the 1/2 minus 1. M to the 1/2 minus 1. Okay? So then this is first. So m to the 1/2 times m to the 1/2. Remember, we add the exponents, so this becomes m. Okay. Then the outside is minus m to the 1/2. The inside here is minus m to the 1/2. And then minus 1 times minus 1 is plus 1. Right? Then on the bottom, m to the 1/2 times m to the 1/2 is m to the first, right? 1/2 times 1/2 is 1. Then outside, minus m to the 1/2. Inside here is plus m to the 1/2. And last, negative 1. Okay? Then, the m stays what it is, since we have negative m to the 1/2 minus m to the 1/2, I now have negative 2 of these m to the 1/2. And then on the bottom here, the negative m to the 1/2 plus m to the 1/2 cancel, leaving me with m minus 1. Okay. So there you go. Doesn't always look simpler. It says simplify. It doesn't always look simpler, but now we don't have a radical on the bottom anymore. Okay, so why don't you try 5a, 5b, and 5c and come check your answer when you're done. Okay, this is what you should have gotten for 5a. You should have gotten 2 to the 11/12, or like this in radical form. For 5b, you should have 2x, and then the cube root of 2x, or this in exponential form. Okay. 5c, you should have gotten y plus 4y to the 1/2 plus 4 all over y minus 4. If you got that right, you can move on to our last example. If not, here is your explanation. I rewrote 32 into 2 to the 5th and changed it into rational exponents. Okay. Then, using our quotient power, it's top power minus bottom power, so that's why it's 2 to the 5/4 minus 1/3. Subtracting fractions require a common denominator, which is 12 in this case, so 15/12 minus 4/12, which is 11/12. Okay. So for 5b, using the product rule, I separated the roots. Okay. I rewrote 16 to be 2 to some power, so 2 to the 4th. Okay. So 4 divided by 3 is 1. So one group of 2, that's why it's 2 to the 1st, with 1 left over. And the same thing goes for x. Okay. And then the exponential form is just rewriting this one as 1/3 power. For 5c, we're multiplying by its conjugate to get rid of the radical here. So that would be y to the 1/2 plus 2, top and bottom. Okay. Then I distribute, so y 1/2 is y. Then this is 2y 1/2, this is 2y 1/2, 2 times 2 is 4. Okay. Same thing with the bottom. Y 1/2 is y to the 1st. Then 2y 1/2 minus 2y 1/2, and then this is minus 4. Then I just combined like terms, so since I have 2 of them and 2 more, that becomes the 4 of them. And then these cancel, leaving me with just y minus 4. Okay? Okay, moving on to our last example. Okay? So if x is a positive number, we want to know what this results in. Okay? So we're using our exponent properties. So the first thing I'm going to do is I'm going to add these. So I'm going to do x to the 4/3 plus 2/3. Okay. This gives me x to the 6/3. Okay. I can change it to 2, but now since I'm going to then subtract, it's going to be x to the 6/3 minus 1/3, which is x to the 5/3. So none of them with a rational exponent has 5/3, so it's not this or this. Okay. Power on top, so this is going to be the power. Root on the bottom, this is going to be the index. So then rewriting it, it would be root power, so that matches with C. Okay, there you go. So why don't you try 6, CYP6, and then once you're done, come check your answer. Okay, you should have gotten G here. If you got that right, you can get started on your homework. If not, here is your explanation. Okay? So y to the 1st times y half, add them together, it becomes y to the 3rd. Okay, then using my quotient property, it's top power minus bottom power, so 3 minus 1/2, or 6 halves minus 1/2, which is y to the 5/2, and that is G. Okay. And there you go. That's it for today. Have a great rest of the day. Bye, guys.